All right. Hi everyone. I'm so sorry about the delay, but we are waiting for your instructor. So while we wait, please let's just exercise patience. Let's exercise patience, please. Thank you very much.
Hi everyone, good afternoon. Can you hear me?
Yes, we can hear you. Good afternoon, Adi.
Okay, yeah, good afternoon. So
We
my
can
name
hear you. Good
is
afternoon.
Adenio. Yes, thank you. My name is Adenio Ulabi, and I'm currently a junior DevOps engineer with Amoye, and I'll be the one handling the live coding session for today. So I welcome you all to the coding session, and I hope we have a great time together. So, just before we start, yes, the recorded session will be available on YouTube, so you can refer back to it anytime to go back and learn concepts that were spoken about. So, without further ado, so I just want to state that this coding session, as the schedule have been posted. So we'll be having 4 coding sessions for stage A, and then the coding session is just to give a very brief overview and introduction of machine learning with Python using different set of tools that are available. So let me share my screen because I'll be sharing a com tab. Okay, so let me just pick up the particular screen I want to share. So today for our live coding session, we'll be working on Numpy and exactly. So can you confirm if you can see my screen?
Yes, sir. We can see your screen.
Yes, it's up now.
Yes, please,
Thank
we
you.
can.
Okay, thank you very much. So um again, welcome to the stage A coding session, and today we'll be working on introduction to machine learning, introduction to Python for machine learning. So we'll be using the slides will later be shared to you guys via Slack, and then we are going to be taking it in steps. So the first thing we'll cover for today, what we'll be covering for today, is the use of NumPy. Then we introduce what NumPy is, how it is used, and um, the kind of features that NumPy provide and how it is used in data science. That's the first stage. Then the next live coding session will move to another very important module for data science. Then the last 2 stages will be talking about a very brief introduction to using data sets and then creating a model for these data sets. Someone said the audio is too low. I just want to confirm, can you guys hear me correctly?
Yeah, we can.
Yes,
Yes,
we
we
can.
Yes,
can.
loud and clear. Very loud and clear.
Okay.
Okay.
So for people that are saying the audio is not clear, so maybe try and ensure that your internet connection is okay because others can hear me. So but I'll try to talk a bit louder also from my end. Yes. So as I was saying, we'll be taking NumPy today. So without wasting much of our time, then let's go to the first slide. And this is our first slide. So we have introduction to Python for machine learning. So the introduction went back on an exciting journey. So whether you're a beginner or ready to dive into the realm of artificial intelligence, this is going to help you with foundational knowledge and practical tools. So while okay, I think someone else is still recording, asking if the recordings, yeah. As I was saying, so while we acknowledge the fact that the field of artificial intelligence and data science is too loud, is too broad. Okay. Um, just to confirm again, because I'm seeing messages on the chat where people are saying
And then we can
they
hear you
cannot hear.
properly. If they can't
We
hear you
can
properly,
actually
Okay.
hear
maybe
you
it's your
properly,
network.
loud and clear.
Okay.
Yes, we
Thank
can
you
hear you.
very
Please
much. So,
continue. Thank you.
um, yeah, I'll quick on. So while we acknowledge the fact that the field of data science and AI is quite a large field, and there are a lot of tools and a lot of tools and ideas, methodologies that one has to learn. We are trying to provide the basic foundation. At least we want to equip people with knowledge that will serve as a stepping stone for you to even achieve greater heights in your journey for data science and machine learning. So Python has emerged as a de facto language of choice for machine learning due to its simplicity and versatility. So Python remains one of the most popular languages because you see, Python is very easy to understand, it's very easy to code in, and people, it's more English oriented compared to most other languages. So this has made Python a very widely used language, and you see, each day we have a lot of new people coming out to create even more tools using Python that can be used for data science and for AI machine learning in general. But it will be it will be an hindsight or a bias, if I put it that way, to not mention that there is another very popular programming language that has been growing prominence also in the terms of artificial intelligence and data science. And the programming language is called R, just the letter R. So it started a few years back and it has quickly risen up to the ranks. So after Python, the next language in line in terms of writing data science applications and using code to run data analysis or Python machine learning models. Sorry, machine learning models. R is the language that is being used. So I advise people to first get the basics in Python because most companies and institutions out there will want you to use Python. But then um, for for to make you someone that is very versatile in the field, it might be beneficial to know a bit of R, but that is secondary. And the main thing at first is to know a lot of Python and to be able to perform any tasks in Python. Then if you know it in Python, then doing it in R will just be a walk in the park because it's almost the same thing that we're doing. So as I said today, we'll be working on Numpy. So Numpy is a short form for numerical Python, and it is a fundamental library for scientific computing in Python. It provides support for powerful array and matrix operations, enabling efficient manipulations of large multi-dimensional datasets and numerical computations. So Numpy basically is the is one of the most extensive modules that you cannot do without. Is probably even the most is probably the most important, let me put it that way, because almost every other module you'll be working with is built based on NumPy. So as the name says, it's numerical Python, and it is a module that is streamlined for working with numerical computations using Python. So in artificial intelligence and data science, numerical computations, performing linear programming, performing tasks that require you to work with a lot of numerous and large numbers is something that one cannot avoid. So using the regular methodology of the most similar thing to arrays, which is what we use in NumPy mostly, the most similar thing is is Python lists. But lists are very inefficient to handle most of the operations that will require for data science and artificial intelligence. So therefore, the creators that came up with NumPy made it with a mind that um they want to optimize Python to be able to work on large computation number and still be able to deliver in fast time. So over the course of the coding session, probably not today, I'll try to showcase a difference in methodology when one uses lists to perform an action and when one uses NumPy arrays to perform an action. So NumPy, as it calls, NumPy exactly to introduce the concept of array, and they are very similar to lists, but more functionalities, and it allows us to be able to work with these pythons as vectors. So for people that have a background in science, in STEM, you should understand what vectors are. So NumPy provides us with a way to perform vector operations using Python. Originally with lists, it might not be possible to perform some of these operations, but the creators of NumPy came up with this method. So we have a lot of, so basically you can perform almost any mathematical operation using NumPy on Python. And that's the module that we talk about today. So more about Python. Some of the key features of Python include number one, efficient array operations. So NumPy's array objects are homogeneous and contiguous in memory, making them ideal for mathematical operations. So when we say homogeneous, that means that a NumPy array can only contain the same data type. We'll showcase this shortly. A NumPy array can only contain the same data type. So with this defined constriction, let's call it a constraint. So this constraint that has been defined that a NumPy array should only contain the same data type makes it easy to perform some functions without having to by like skipping some steps. So let me give you a very easy scenario. So let's say you have a Python list, and in Python there is no constraint on the elements that the list can contain. So the list can contain a string, it can contain an integer, it can contain a tuple, it can even contain another list itself. You get. So let's say in a scenario where you want to perform a sum operation. So you want to sum all of the numbers that are inside the list. Due to the fact that you are not sure if the list only contain numbers, or if the list contains just data type that can be summed up together, we have to start performing some functions. The first thing we have to do is we have to check if the list contains data types that cannot be that cannot be summed up together. So, or after that, then we now need to know, okay, after getting the data types that cannot be summed up together, we probably now have to remove them from the list before we can now perform the operation of sum. So one very inefficient way to do this is that you might probably have to use a for loop to loop through each and every item that is inside that list before we can perform the operation. So this is not efficient in the sense that imagine you want to perform this for a list that contains, let's say, 1,000 items or 1,000,000 items. So you have to do a for loop that will go through each and every item in the list 1,000 times or 1,000,000 times. And this will allow your code to run slow, or it will even allow your code to not be as efficient. Imagine you're doing this in production. So that's why NumPy was created with this constraint that okay, it can only contain numbers. So when you want to perform any operation, there's no need to perform all of these checks to understand if the operation what is going to go through or not. At least I mean at the most elemental level. So operations like sum, operations like multiplication, all of these operations that you want to perform for numerical objects, for numerical data types, for numbers, you are sure that because of this constraint that has been placed on NumPy arrays, these operations will be performed successfully without any error. So an array can only be created if the array stays true to the constraint that has been placed on it. So you understand that any operation you want to carry on, as long as the array has been successfully created, then you can perform all of these mathematical operations. So that's one way, efficient array operations, that NumPy has made working with arrays and numerical stuff efficient. And just as I mentioned earlier, another key features is vectorization. So you see, and this also implies what I just stated previously. So instead of going through every element individually, so you can do vectorized operation where the entire array, a particular function can be performed to the entire array simultaneously. So what are we trying to say? This is another example. So now imagine with a Python list, for example, if you have a list of numbers in Python and you multiply it by a scalar value, what will happen is that the item in the list will get repeated twice, sorry, three times. Let's say you have a list now that contains a data. Let's say the list contains just two. If you say that list item and you multiply that list item by two, what is going to happen is that the value in the list will be repeated by the number of times they are multiplying it by the scalar function. And this is not the kind of operation you want to be performing for numbers. So if you want to do something with Python list where you want each element in the Python list to be increased by a particular value or to multiply by a particular value, you have to do a for loop again, or you have to loop through each of them, and then multiply that value, multiply the previous value by the new value you want to multiply it, and then also do a reassignment to save the new response that you get from this. So all of these are inefficient method of performing calculations that it will make working on real life solutions very very complex, because you waste more time even waiting for your solutions to get completed before your solution can get to being used. So therefore, NumPy provides us with this virtualization where you can now say, okay, even if you have an array that contains 1,000 elements, I want to multiply each and every element in this array by 3, and automatically NumPy will multiply each element by 3 and give you a response that contains all of the elements. And this is done in almost real time, where the operations are done very very fast and you won't even operate it. So another key feature for NumPy is broadcasting. So broadcasting is what allows us to work with arrays of different shapes and size, and it aligns them. So to try and explain this now, let us say you have you have you have an okay, let me use the list example as I've been using. So you have a list and the list contains 3 items, okay, and then you have another list that contains 2 lists, and each of those lists contains 4 items. There is no way you can perform an operation that can combine these 2 lists together, because in list, when you want to perform concatenation and sort of some of these operations, it has to be of the same size before you can perform this operation. In NumPy, we also have some operations that you cannot perform on arrays that are different sizes. For example, for people that are knowledgeable about matrix, if you want to perform a matrix multiplication, you cannot perform a matrix multiplication unless a particular condition is met, which is that the column of the first matrix is equal to the number of rows of the second matrix. So there are some operations that even based on mathematical method itself, you cannot perform them unless they meet particular constraints. But with NumPy, it helps us at least to be able to perform some features, which is called broadcasting. And before the live coding session ends, you see a very very brief sample of broadcasting being done while you're on NumPy. So another feature we have is multi-dimensional arrays. So with NumPy, we also have the ability to create arrays that are multi-dimensional in nature. What do you mean by multi-dimensional? So mostly an array is 2 by 2. The size of the array, you always have 2 numbers. I will showcase what I'm trying to say. When you check the size of the array, you just see 2 numbers being shown. So that's an array that is bi-dimensional. Like the normal array is an array that contains, let's say, 2 rows and 1 column. Let's use matrix abstraction now. So a normal matrix contains, let's say, 2 rows and 2 columns. It contains 3 rows, 4 columns. It can contain 10 rows and 500 columns. But then we can have multi-dimensional in the sense that you can now begin to have arrays that have um a shape of 3 by 3 by 3. So we are trying to now show that, okay, in one row there can be what another there can be a data type that also has another row and columns. Then when you move to the next row, you also see more rows and columns in that data type. So that's a way of abstracting it, but it is called multi-dimensional arrays, and you also see them being done in this live coding session before it comes to an end. So this is just basically a brief overview, because everyone in this stage is taking the same course. So as the internship continues, moving on to stage B and further stages of the internship, you will see that you start specializing on different aspects. So for people that will be specializing on data storytelling, you'll be introduced more to libraries and operations that you will use in performing storytelling or aggregation of data, performing plots using things like matplotlib and the likes. That's for storytelling. For people that are going to go more into data science proper, you've been introduced to modules, sklearn, and other modules that can be used, that you can teach to make predictions. So these modules can make predictions about data. Then you'll be taught about how to use libraries like NumPy and pandas to work with real life data. And while for people in the data engineering sphere, you probably not use some of the modules that we have spoken about today, but it will be critical, because there will be cases where you have to showcase how to place all of these machine learning models that are being created to deploy them. So creating pipelines of how your data can get from the source to the machine learning model. That's majorly what you'll be focusing on for the data engineering track. And you would majorly use Python as a language itself rather than the modules that are used for data storytelling or data science predictions. So the that's a brief overview of NumPy as a module and what I'm going to be doing. So this now is the Colab notebook, and after the end of the coding session, this notebook will also be shared with you guys, so you can have it for reference and just in case. So I'll be connecting to the NumPy. So sorry for people that are just joining the cohort also. So going forward, this is called Colab. In case you don't know what Colab is, so Colab is another method for you to run data science and Python codes without having to burden your system. So instead of using Python installed on your local system or using Anaconda, because one of the major tools that people install to work on data science tasks is the use of Anaconda. So rather than having to use Anaconda, you can just work on Colab, and Colab is hosted on the cloud. So you just need your internet connection and your browser, and then you can perform all of these operations without having to burden your laptop. And then when you are done, all you just have to do is to save the notebook and then follow the steps to upload it to your GitHub page to make submissions and what have you. Um, so just to confirm, just confirm that you can see my Colab page where I have a Numpy and it has switched from what I was presenting earlier.
Yes, please, we can.
Okay, thank you.
Yes, you can see it.
It's
Okay,
tiny.
okay. Let me just try and increase the font
Yes.
size. Okay, is it better now?
Yes.
Much better.
Thank you.
Yeah. Okay.
Please increase it
So
more.
increase more.
Yes,
Okay.
it's better. Okay, can give more.
Yeah, it's
How
better now.
about
It's
Better. It's
better.
okay?
better. It's
Perfect.
better. It's better.
Yeah, no problem. Okay. So sorry, was someone saying something? Okay. So to go in, so let me just show you a brief content of everything we are going to be doing. So this is our content and everything that we have. So we have NumPy, then we'll be showing each of the different operations that I just mentioned and how it is done in NumPy. So we have efficient creating arrays, performing operations, applying mathematical functions. Then we also have vectorization. Then we also then move on to broadcasting. We also then move on to broadcasting. Then we'll show, because if you remember that I mentioned that NumPy is probably the basic module that almost every other module that we're using for data analysis works on. So we'll see how NumPy has been integrated. Sorry, can that person mute their mic if they are not trying to ask a question, so you won't disturb us during the class? Yes, just to go briefly through the chat session. Yes, data or network intensive. It is not data intensive actually. It doesn't take too much for you to run Colab, and it is better, especially for people that are starting out with systems that cannot actually run some of these tools, because um, um, the tools that you use for some of these tools, you might have systems that cannot handle the power. So Colab is a way for you to just use it online without having to stress your laptop too much. Okay. Um, okay, I'm seeing a message by um OBAK Cynthia. So OBAK Cynthia, you can probably make all of this known probably by the end of the live coding session if you have enough time, because we have just 30 minutes more till the end of this session. So you can also share the collab notebook will be shared. So, but to Cynthia, you can maybe ask these questions via Slack for you to get more clarity on what the live coding sessions are and what we do in the live coding sessions. So going back to our collab notebook.
Sorry, I want to ask you something.
Okay. Sorry, please make it short. Just if it's something I can answer, I will. But if it's something that will answer by Slack, then I'll let you know. I can hear you.
All right. Please, when you're done, not now, you can continue, but just walk me through how I can do this collab thing again. You talked about it, but I didn't get it properly. So I just wanted to continue.
Oh,
Then
okay.
after the whole thing, you can tell me how
Okay.
to do it.
That's something I can just do shortly. So to use Colab, when you come to your web browser, just this a Google page, you just come here. You can just type Colab, or to make it easy, you see this Google. So you can type Colab Google on your Google page and just search for it. So the first option you are saying, this is Colab. So this is what you need to run Colab. So you can click on the first option. When you click on this option and it opens up, then all you just have to do is that you need to click on Open Colab. So when you open Colab, or you can click on New Notebook, any of this. So if you are someone that wants to create a new code, you can see it's hosted Jupyter Notebook service, and you also have access to GPUs. So over time, you learn what GPUs are and how they help you when you are creating machine learning models. So you can just click on New Notebook. If you click on a new notebook, it takes you to a new page where um, a new collab notebook could be created. And another good reason for using collab is that most of the modules you want to use, they come pre-installed on collab, in the sense that you don't have to start installing. For example, if you're on your local system, if you want to use a new module that you have not used before, you most likely have to install this new module, and this will take space, and it might also burden your system more. But on collab, most times you won't have to download or install this module because it comes pre-installed. And even if you have to install this module, the installation will take place on the web, and it will not what affect your system. So when you click on the new notebook, this is a new notebook. You can change the name of the notebook. So this is how you rename the notebook. And then any code you type in here, once you run it, you just click on play, or you can click on shift and enter. Your code will run, and then you can interact with your code. So you can also click on Open Colab. When you click on Open Colab, you see a list of all of the notebooks that you have created previously, and now you can interact with them. So that's basically so you can see these are my recent notebooks that I've created. You can see popular examples of how you can use Colab, how your Colab is linked to your Google Drive, and other features that Colabs provide you. Okay, so let's go back to the main notebook that I'll be using for today. So the first the first thing we'll be showing is how to create numpy array. So for you to use any module that is not a standard built-in module on Python, you have to you have to import um the module. That's why you can see that for all of my code here, I'm having something called import. But one thing you should know is that with Colab, once you have done an import once, you don't have to import it again. You understand? And I will show you that. So I can just move this here, this import, or let me leave it here. Then for subsequent rows, I can remove um the import statement, and you see that the module will still work. So you don't have to recall anything that you have said previously. You can Colab is a Python environment, so it remembers anything that you have defined, any variable, any modules you have imported. So you don't have to repeat it. So import numpy as numpy. So this is the first syntax. Most times when you want to use numpy, you have to import the module. So instead of us to be typing numpy every time, we just use this abbreviation np. So this is the standard. These are standard ways that this module is used in Python in general, in the world of data science. Let me just put it that way. So it is not a must that you must import numpy as np. You can decide to import numpy as n or whatever you like. But the general standard, when you see most code solutions, when you see most solutions out there, you use import numpy as numpy. So creating a 1D array. So this is how you create a 1D array. You just have to define the array. So there are a lot of different ways that you can create arrays. One of them is to use lists. That's the most popular method, using lists. It's possible to use dictionaries to create arrays also, but that's probably not going to be done for NumPy. For NumPy itself, you see that when you are doing things like pandas and whatever. So when you want to create a 1D array, you use np.array. So when you say np.array, then you put the list that contains the items of the array that you want to create inside that function, and then your array gets created. So I'm going to run this code now, and you can see that the array has been created, and I'm printing out the array. So you can see that the 1D array is printed on just one line. So it is just like basically you creating a list, and this is just a list that contains 1, 2, 3, 4, 5. But instead of it to be a list, it is now an array. So let me show you how you can confirm that it is an array. If you come here now and say type of array 1D, let me just pick this whole statement here. Let me paste this, and I run this code. You can see that it is saying that the type is a what? Is a numpy nd array. So this is a non-dimensional array. But if I remove this function here that takes away the array and just call this normally, you see that the type is going to be a type of list. So to create an array, you just have to embed the list inside the array, and then you convert it from a list to a numpy array. So for the 2D array also, if I say what is the type of the 2D array, sorry, array underscore 2D, and I press enter, you'll see that this is also a numpy array. So what do you mean by one dimensional and two dimensional? So numpy provides us with a method called shape. So when you want dot shape on any numpy array, okay, sorry, array 1D. So when you want dot shape on any numpy array, you will see the shape of the array. So for one dimensional array, you only see a figure there that tells you that okay, this is the length of the array. What does length mean? The number of items that is existing in that array at that particular time. So you can see that this just has 1, 2, 3, 4, 5, which is 5 items, and that's why the shape is showing us that okay, this is a one-dimensional array with 5 shapes. Then if I change this and change this to array 2D, and I click on Control Enter, you can see that this is now a 3x3 array, and a 3x3 array is showing us that this is an array of a 2D array. So based on the shape, you can know if it's a 1D or 2D array. And to create a 2D array, you just pass in a list of lists. Let me just copy this here and then paste it out. So you see that this is a list of lists. This is one list that contains what? 3 other different lists. But one thing you need to know is that you cannot create an array, just like I said, for homogeneity. So if I come here, let me just pick up this whole line, Control C, and let me paste this here and try and change one value from a number to a string. Let me change this to we, and I run this. Okay, this is getting created, but if I specify the d type, that the d type should be of type int, then this should probably throw an error. You can see that it is showing an error that we is not a string, so therefore the we, which is a string, should not be contained in an array that should only contain what? Should only contain integers. Previously, it used to throw this error automatically, even if it did not specify the d type. But due to the fact that over time people have seen the need to have numpy arrays that also contain strings, so they have removed it from being the default action. So now if you don't want a array to take in any string, you have to specify the d type. But one thing that is not going to work is if I change the length of this array. We can see that in our list of lists now, each list has 3 items. But if I change this item to be 2, it should throw up an error that this is not homogeneous. You can see it is using the word itself, homogeneous and inhomogeneous. So creating an array where each of the item is not the same, that means we are expecting that okay, for example, if you are going to be having an array of shape 2 by 3, then every item in there should contain the same structure. So what are we trying to say now? You know that from the shape of the array, let me just create a new code block and do array underscore 2D, then show the shape. Okay, and you can see that the shape is sorry, there should be a D here, and the shape is what? The shape is 3 by 3. So what this is trying to tell us is that we are going to have 3 rows, and for each of these rows, every item should contain what? Every item should contain 3 values. So 3 rows and 3 columns. So when we remove this particular value from this other list, that means we are trying to create 3 rows. So each list represents a row. So you can see 1, 2, and 3 is one list, and it is representing the first row here. 4, 5, and 6 is another list, and it is representing the second row here. So what we are trying to tell this here is that for the second row, we want it to contain just 7 and 8, which is not going to conform to the structure that we have already provided for the first and the second rows. This is why it is telling us this error that it is not homogeneous. So if you want, if I just come here now and remove, oh, sorry for that disturbance. Okay, as I was saying, if you want to change the shape of the array, so as I've changed it now, where everything is 1, 2, every item is containing just 2 items. All I just have to do, if I run this now and print out the shape, you will see that the shape of this is going to be 3 by 2. So now I've told you that, okay, based on the structure that I've given it, I want 3 rows. That's why I'm providing 3 different lists and 2 columns. So each of these columns, each of these rows will contain just 2 values. So that's a very, very basic overview of how to create arrays in Python. So the next thing we have is performing mathematical operations. So what we first did, so if I come here and I remove this MP, just as I stated previously, and I run this code, the code will still run without giving me an error because I've imported Numpy previously. That's a function of Colab though. And so it's Colab understand that MP is referring to Numpy. So that's just a way of saying. So this is we creating 2 arrays, and then we want to add both arrays together and want to multiply both arrays with each other. So you can see now that once we convert it to array, when we added the arrays together, the addition is just an element-wise addition, and this is only achievable because it is what? It is an array. Just to showcase it, if I create 2 lists, let me create a list called 1, 2, and 3, and then let me create another list that contains 4, 5, and 6, and I run this code. You will see that this will just create a new list that contains every element in the separate list that I've contained. And this is not a mathematical operation. So Python list does not give us. So if I want to perform, if I want to get this same results, the result of this addition, I just did addition, I have to use a for loop and say, okay, for every element, for elements in, let me provide 1, 2, 3, then I even have to first create I have to create one list. I will take the answer. So this is like response. Then I'll say for each element in 1, 2, 3. For each element in 1, 2, 3, then I'm also going to have to probably say for then for each element in 1, 2, 3. I think that's a I don't want I don't want us to take too much time. So for each element, I do not want to take much time, but I don't want to give you code that's going to be too much. So let me just say list A is this. Sorry, let me just paste this. Then let me say that list B, Control C. List B is also equals to this. Okay, C. B is also equals to this. So for me to get the same thing using this, so I need to say for I in range, the length of A. Okay, so I now need to res.append because I did not want to use 2 for loops. It was possible to use 2 for loops with the way I wanted to provide it before, but that would take too much time. So for I in range, okay, it's flagging this range. Exactly. For I in range, this append what's A at I plus B at I. So I did not print out this. So let me print out the results. 5. Print, okay, there should be a T here. Print results. So you can see I've been able to get 5, 7, and 9, but see the amount of code I had to write. This is the code I had to write. In a sense, it does not look large, but it's when your array begins, when your list begins to get bigger, that's when you begin to see the kind of operations. But with NumPy array, you don't have to do all of this. You just need to add the two arrays together, and you have the result of the addition. Let me also show multiplication in Python, and you see how multiplication for lists. So if I do something like A times B, I think it should give us an error. It should give us an error that multiplication is not supported. So you can see is you cannot multiply a list. But yeah, I was able to multiply two arrays by using the multiplication by using the multiplication operator. So this is another feature that Numpy provides to us, because with Numpy you can start performing all these elements. Also in Python, if you multiply a list by just a particular value, what you see is that it will repeat the list 3 times. You can see list A contained 456. What he did was to say, okay, 456 the first time, 456 the second time, then 456 the third time, and return that result. That's what multiplication by scalar does. But with Python, sorry, with an array, when you multiply an array, so let me multiply the array 1, and I multiply it by 3. What you see is that each element in that array will be multiplied by value of 3. So what's in array 1? Array 1 contains what? 1, 2, and 3. So if I multiply 1 by 3, what's the response? 3. If I multiply 2 by 3, I have 6. And if I multiply 3 by 3, I have 9. So this is another feature. So with Numpy arrays now, you can start seeing each element. You can take it away from being a list, and you can start seeing that, okay, you can start performing operations with all of these values that are contained inside the list. So the next thing we have here is applying mathematical functions. So NumPy gives us different mathematical functions, a lot of different mathematical functions actually. I'm just showing two of them. One is the square root, and the other one is the exponential. So in this array, after I created this one-dimensional array, what I'm doing is I'm getting the square root of each item. So with Python now, with NumPy and with the arrays in NumPy, any operation you perform is performed to each element that is existing in the array. So me calling NumPy.square roots on this array, what did it do? It automatically computed the square root of each and every item that is existing in this array. So the square root of 1 is 1, the square root of 2 is 1.4, blah blah. The square root of 3 is 1.7, the square root of 4 is 2, and the square root of 5 is 2.23. That's the NumPy.square root function. We also have the exponential. What exponential? Exponential, the method is also the same. It performs this mathematical function on every item. So the exponential of all of these functions is what we have here. So this gives us a better way of performing action, because for each of these actions that have been stated previously, if we wanted to perform these actions using a list, would have had to use a what? Would have had to use a for loop. Um, would have had to use a for loop, and the for loop is what we'll use to perform all of these actions. But NumPy array has given us the ability to perform these actions in easy time. So element-wise operation, this is just basically we showing element-wise operation. So everything I've been saying about each operation happen to each element in the array. That's what we call element-wise operation. So it's just that's the actual tape, just trying to show you. So this the element-wise operation, where each operation you're carrying out happens to each and every element that is occurring in that list. So now this is broadcasting exactly, and I showed this previously in a way. So broadcasting is what allows us to be able to perform multiplying each element in an array by a particular value. You remember when we tried to multiply a list by a scalar value, it just repeated lists. It just repeated the list. It just repeated the list, and when it repeated that list, it did not perform mathematical operation on them. But with broadcasting, we can start to perform what different values. That's why we can have a scalar. For example, in this now, previously I used a 1D array. So let me also show you that even for a 2D array, the same thing. So this is the 2D array that I just created, and the 2D array contains what? The first row contains 1, 2, and 3, and the second row. So if I add 3 to this 2D array, you see that every element in this array has had 3 added to it automatically. You can see we have 4, 5, 6. 1 plus 3 is 4. 1 plus 2, sorry, 1 plus 3 is 4. 3 plus 3 is 5, blah blah, and stuff like that. So that's the essence. That's addition. If you also do some multiplication also, um, multiplication, you also see that this will also happen. You can also try to do multiplication with another array. But just like I said, to multiply with another array, you have to follow the rules of of matrix multiplication. So let me try and multiply this by a one dimensional 1D array. If I try to multiply it by let me say 1, 1, based on the shape of this array has a shape of 2, 3. Let me just show you. This is something that is known universally in mathematics. So this is the shape of this array. This is 2, 3. So me creating this other array here, and I print out the shape. You see that the shape of this array is okay, sorry, this should be array. I missed an A. So the shape of this array is just 2. So for you to be able to multiply two matrices together, the value you have here must be equals to the value you have on this side. So if I come here now and try to multiply this array together, you can see that it is giving me an error. So you cannot broadcast. So what it's still doing is called broadcasting, but you cannot broadcast this shape together. But if I just try and increase this and add something like 2 here, and I do this, you see that this was able to broadcast. Why? Because if I check the shape of this now, you see that the value here, which is 3, is now equals to the value here, and therefore you can multiply this array. I can also try this too, and let me try it for a 2-dimensional array. Let me try and create a 2D array. Let me just do this, comma, let me put 2, 3 here, and then here let me put 4, 5. Okay, you see that it is giving me an issue also. It's telling me that okay, you cannot do this. Let me just print the shape of this array here, and you can see that the shape of this array is 3, 2, 2, 3, and 3, 2. So although this here, this value here is equals to this value here, but Numpy is not able to broadcast the two shapes together because it is trying to perform this in an element-wise operation. Let me see if I have something about matrix here. Okay, I don't have anything about matrix. Okay, but if you want to try and do the matrix multiplication, you have to just do I think when you do the np dot multiply, I think if you do the np dot multiply, then you should be able to perform the matrix multiplication just as it should be. Okay, still giving the same issue. I can just check this here, but that will waste much of our time. But for you to multiply two arrays that are 2-dimensional together using NumPy, okay. Okay, sorry, let me just get to the previous exactly. So you need to ensure that both of them are in the same shape. So if I convert this now from 2 to 3 and reverse this shape, let me make this shape now another 2, 3 array. Let me make this equals to 4, and let me make this equals to 5. Then you can see that we have a result. So what did this do? What this did is it multiplied each and every item here in this our original array. Our original array has 1, 2, 3, 4, 5, 6. So 1, let me just print out both arrays for you so you can see what was done, and that's trying to show you what broadcasting is. So let me print out this array, and then let me print out array 1. Okay, so you can see that sorry, this should be AR. So you can see that for the first array, so what it just did was it multiplied the first value here in this first row, it multiplied it by this value. That's 1 times 1 is 1. Then it took the first value, the second value here, it multiplied it by the second value here 2, and it took the third value here 4 and multiplied it by the third value here 3. That's 12. So this is trying to do a broadcasting. But then when you want to treat the array as a matrix rather than just a regular array that should be broadcasted, then you can perform matrix operations I'll still show you. We have just 5 minutes to the left of till the end of this. So once I'm going through all of this, I'll be a little bit faster. Then I'll show you how you can get responses, or when you are working with a new module, like NumPy, for example, where can you get tips for how you can perform whatever it is you want to perform. So universal functions, um, universal functions are just basically sine functions, cosine functions, and that's just me showing that okay, all of these mathematical operations. So you can see here we have np.sine, we have np.cos. We can also do the same thing. Let me just copy this here. Let me put another code and let me paste this and change this to np.tan. np.tan. And if I do this, it also give a result. So you can see the result is of that's I did not change it. Okay, just to avoid any error, let me change it to result.tan. Let me change this to result underscore tan, and then result underscore tan. So you can see now that the response, this for the values for sine, the values for cosine, and these are the values for tan. And you can immediately perform an action. So let me just pick this here, this array. Let me get the tan values and then divide everything by 4. You can see that immediately this value here, after performing this operation here, automatically divided each value by 4. So that's an element-wise operation where you can perform multiple operations using array. So I've showcased this one. So this broadcasting proper, where you can just broadcast scalar to an array with different shapes. So you can, I've showcased this previously. Then broadcasting an array with different shapes. You can see it here. So this is me just trying to show you. So if I run this code, you can see that this array here that has just one shape was broadcasted to this array that has 2 shapes. Let me just show it. Let me show it in real time. Let me print array 1 and let me print array 2. Okay, so you can see this is our result here for adding both arrays. So what this did was it just took this first array and added the value to each of them. So 1 here was added to 10, it gave us 11. 2 was added to 20, this was 22. 3 was added to 30 and it gives us 33. But because this is a one-dimensional array, and the one-dimensional array is following what the number of columns that each of these values have, or not even number of columns, I think is the number of rows. We can confirm that. Let me just pick off these two here. So just to, sorry, Control Z, to showcase another aspect of okay, so this addition. So yeah, let me print out the shape. Okay, so you can see this is the addition of both of the arrays, exactly adding 2 of them together. But if I come now and let me change this one to like 5 and I press Control and enter, you will see that this will not be array, because you cannot broadcast something that has a shape of 4 over something that has a shape of what, 2, 3. Or if I come here now and say that okay, this has a shape of 4, and I increase because for this now, this has 2 rows and 3 columns. So let me try now and increase the number of columns in this of this now. Let me increase it to 4, 60. Let me make this 70. So this should be 70. And I run this. You see now that this should run successfully because each of these arrays. So when you're broadcasting, you need to have an understanding of the shape of the 2 arrays so that you can broadcast both of them together. So this is the part of integration with other libraries. So the first library that will be showing integration with is pandas. So for all of these, I'll not be doing a deep explanation because we'll still talk on all of these libraries one by one. Today we are talking about NumPy. The next live coding session will be talking about pandas. So what pandas does, it creates a DF. So you can see this is a NumPy array. But if I come here and just print out DF, this is DF, and this DF was created from a what? From a dictionary. And if I print out this df, you see that it will give us this array, but the array will be given in a tabular format. You can see instead of having 1425 just written with brackets, it's giving us this array in a tabular format. So that's what pandas does. It gives us a way to work with arrays, but instead of just working with arrays in values, we can show them in a tabular format and perform operations as if we are working with a table. That's what will be the focus of the next live coding session. Then this is matplotlib. So what matplotlib is used to do is matplotlib is used to plot. So this will be one of the most important libraries for people that will later focus in data storytelling. So this is we created a linear space. So this linear space means a different linear values that fall in between the range of the smallest number and the highest number. If I come here now and print out x, you see that each value in x is going to be different by the same number, because the length of x is is 100. Control and enter. You can see that this length is 100. So, and that is the 100 that was specified in this place. So if I say X and press Control and enter, so linear ensures that each and every item, so the difference between the second item and the first item is also going to be the difference between this item and this item. It's also going to be the difference between this and this. So that's what linear space does. It creates a linear sample of linear values based on the numbers that we provide. And then after getting the linear space, we calculated the sign of each of those linear values. So this linear space, what it returned to us was a numpy array. So because this linear space is also x dot shape, or let me just say type of x. So if I do the type of x, you see that x is a what? X is an array. So that's when you do np.linspace, the result you get is an array. So that's why when we performed np.sign x, every value in that linear space that I just showed, the sign was performed just like numpy would do normally. Then we now use matplotlib to just plot what you see. We just provide the two arrays because x is an array on its own. Y is also another array. Let me confirm that y is also another array. If I come here now and do type of y, oh sorry, I wanted to, okay, if I come here and do type of y and I do control and enter, you see that the type is also a what? A numpy array. So these two arrays were just provided to this matplotlib. So you can see I imported matplotlib as plt, and this is this. So in the third coding session, we'll be focusing on matplotlib, where we'll be using both pandas and numpys to create different types of plots and try to see how you can use these plots to analyze the data that you have. So that's what we're doing for the third coding session. And then this is SciPy. Just like NumPy is numerical Python, SciPy is science Python or scientific Python, or as any you want to call it. So SciPy also uses NumPy a lot. So with SciPy, you can start to perform scientific operations. NumPy gives you numerical operations, most of mathematical stuff. But with SciPy, you go a step further in having scientific operations. You can perform functions like correlation, like getting p-values. You can perform hypothesis testing. You can use that to get losses and all of those scientific operations that can be performed with numbers, sampling, by Poisson distribution, and what have you. Those are contained in the SciPy module. For people that are going to be focusing on data science, SciPy is also another very important module because you will need you to at least perform some testing and analysis before you fit a model on your data. So what we are using from SciPy here is the inverse. And what this does, it just gets the inverse of a matrix. And you can see that to use the inverse, we just provided, this is a numpy array that we created. And then we just pass this numpy array into a function that we get from SciPy, and it gives us a result. And the result of this matrix is also a numpy array. So you can see that these four modules that I just showcased to you, they rely heavily on NumPy, and there are even more like TensorFlow, sklearn, a lot of different libraries like that use NumPy as the basis of their calculation. So NumPy is one of a very, very important module that we need to understand how to work with. And then this is just me repeating multi-dimensional arrays. So there are some things that I have omitted sort of, in the sense that some operations. So you can see this is a 2D array. So if I let me exactly. So if this array I told you that we can have a 3D array. So let me just pick this array here, and let me get the let me get the shape of the array. You should see that the shape of the array should be it should show us 3 numbers. That this array, okay, I'm just trying to sort something on my laptop. Okay. So if the shape of this array dot shape, and I press Ctrl and Enter, you'd see that it will give us 3 values. So this is 2 by 2 by 2. And to create it, how did we create it? You can see we are still using the same idea of a list of lists, but now each list is now containing another list. So basically, the idea is that the type of shape you want to create is based on how you provide the list to Python. So previously, when we wanted to create an array, a 2D array that has just 2 numbers, we just provided it with a list that contained multiple lists. But now here we are providing it with a list that contains multiple lists, and each of the item in those lists is also another list on itself. So with that, we are able to create a 3D array. So to showcase how to get in there, so this is called slicing. So if I show this, you can see. So let me just do this. Let me print out the whole array first. So this is the whole array. So the way you get, just like in Python indexing, just like in Python where you index, okay, we have a list. Let me say I have a list of 1, 2, 3, 4, 5, and I want to get the fourth item. The second item. All you just have to do is to provide this in an index, and you will get the item. So the second item, remember that Python starts indexing from 0. So the 0th item is 1, the first item is 2, then the second item is what? Is 3, and that's why we have 3 here. So the same thing also comes for arrays. So if I try and get just one item, you'll see that it will give me the whole list that occurs. You see, this is the whole array that occurs at, even because this is a 2D array. So when I try to get just one element at that position, it gives me the whole row that is in that array. But for this now, this array here now, if I get the shape of this array, you see that the shape is 1D. So for this 1D array, if I now try to index again and say, let me try to get the second element, and I say Control and Enter, you see that it give me just one value. So the value in the first row, the value at the second position in the first row is 3, and that is what this is. So that's how you index. And aside from indexing, you also have slicing. So let me try and create an array that contains more than these values, and let me say C is equals to let me give it a stop at 6, 7, 8, 9. Then let's go again, 11, 12, 13. Then let's go again, 14, 15, 16. Okay, so I think with this we're good to go. So this is C. Oh, there's a P here. This is an error. There should be no P. And there should be no D. Okay, MP. So that's me. I've created an array. So if I take the shape of the array, C dot shape, so you can see it's just 2 items, C dot shape. So now if I say that, okay, for C, give me the elements up to the third row, you see that it will give me just 3 items. So this is the first row, the second row. Let me print out the whole of C so that you see what C is. So this is the whole of C. So you can see C has what? 5 rows and 3 columns. So it's slicing up to the third row. It's giving me the first row, the second one, the third row. If I swipe up to the second row, it's give me the what? The first and second row. If I don't put any number, it means I want to slice up to the end. It gives me the whole row. So you can slice for row. You can also slice by column. So let me see, after I slice for this row, then I can now say that give me up to the second item. So you can see, okay, this is slicing by, okay, no, I want to slice it by the column. To slice it by the column, I think you have to provide two. Okay, so to slice by the column, this is still giving me the first item. There's a method to slice for the column also, but I can't remember that off the top of my head. So probably at another time you can do that. So this basically a very, very brief and short introduction to NumPy and how you can be using it in most of your functions. So that's not all. Like I said, it's very large. So I want to direct people to a site. They call it W3 Schools. So you can just say W3 Schools, then NumPy. So if you say W3 Schools and NumPy or whatever you type here, but once you type the correct stuff, you see this is NumPy tutorial. So this NumPy tutorial from W3 Schools, it's a very, very wonderful introduction to NumPy, and it gives you everything about NumPy: indexing, slicing, data types, copy versus view. These are a lot of things that I cannot you can see this the universal function. These are a lot of things that I can talk about in 1 hour, but are things that you probably need. Like with NumPy, you have something called reshape. You can reshape an array, you can join an array, you can split all of these here. So if you come to this tutorial, the NumPy home, and you can take all of these tutorial checkpoints here on the left side of the screen. I hope everyone can see my screen.
Yes, you can see your screen.
Okay, thank you. So if you go to W3 schools, so after going through the course materials in your leisure time to gain more, because like I said in the beginning, it's not possible for us to be able to give you all of the so it's not possible for us to be able to give you all of the knowledge that you will need to work in practical scenarios or to create different solutions. It has to be a conscious effort on your end also to try and learn new concepts, learn different things where you see how you can use this. So you can use this W3 schools tutorial. I recommend it because it gives a lot of introduction and tells you a lot of different things that you need in performing arrays with NumPy. So I'll just copy this here and then I'll paste it on this chat box. So I've pasted that on the chat box. You can use that. Then another very, very important place where you can see a lot of actions, a lot of things about not only NumPy, about any module is the documentation of that module. So for every library that you'll be working with in Python, as long as the library exists and the library can be installed using pip, that library must have a documentation. And see, this is their documentation, and they have a manual, they have a user guide, they have a lot of different things. So if you go to the web, they have a lot of different tutorials where NumPy itself, the documentation, because even everything in NumPy is just Python code. So the documentation is everything you need to get started. So if you say the absolute beginner's guide, so it is installing NumPy, how you can install it, you can see reading example code, what's the difference between a list, why do you use NumPy, a lot of different things. And then you can come here, the fundamental usage. I think exactly you can click here, fundamentals and usage. So how to create an array, indexing, input and output. Input and output means reading files. So with NumPy, you can even read files. There's a way you can save NumPy arrays to files and read them in. A lot of different stuff that is not possible for us to show you in 1 hour, or even use the 2 weeks, which is the duration of stage day, to show you, because they are too wide. So it has to be a conscious effort on your export, on your part also, for you to want to learn these things. So you look for more materials to boost your knowledge based on the foundational knowledge I'm providing you with. So with that, we have come to the end of today's live coding session, and then we'll be meeting next week. That is Monday, I believe, for the second part of the coding session. Any further questions you want can be directed on Slack. Just tag coordinator or I'm admin, and we'll try to answer all of your questions. And you can also help for people that have a little bit of experience. The coding session on YouTube is immediately after this session, you find it on YouTube. So if you have a little bit of experience, try and help your peers wherever they have issues. I think I've been noticing some people also that try to answer questions. So do have a wonderful day, and we have come to the ending of the live coding session. Bye bye for now and see you guys next week.
All right. Thank you, Adi. Thank you very much for your time.
Yeah, bye. Thank you very much.
Bye.
Bye. Thank you. Is there any link to this month's attendance or not? Right.
Thank you very much.
I'm not audible late.
Thank you. Goodbye.
Thank you.